Hello and welcome. My name is Tuong from AIOZ. I would like to introduce our paper, Grab Person Signature for Person Re-Identification. Person re-identification aims to retrieve a particular person image in a collection of images captured by multiple cameras from a various viewpoints across time. In this work, we utilize the person attribute information with its associated body part to encode the visual person signature in one unified framework. This figure shows the effectiveness of our approach. We treat body part region in attributes and nodes in a graph and then leverage graph convolutional network to learn the topological structure of a person's signatures. Illustrated on the screen are proposed framework. The rough image is first passed through a backbone CNN to get the feature map. Then the human parsing retrained model is used to extract the body part mass and visual feature of each part. The person attributes are then represented by a lookup word embedding, giving body part feature and attribute feature. We construct the graph a person signature, which include attribute nodes and body part nodes conditioned on the correlation matrix. We apply the GCN for reasoning on the person's signature graph and encoding the graph into more representative feature. Our method is a multi-brain multi-tap framework, which is comprised by a main brain and an auxiliary brain. The main brain performs the verification step by optimizing triplet lot and center lot. The auxiliary brain performs the reasoning on the person's signature graph and so the attribute recognition. We move to the experimental result. First, we will talk about application studies and then the comparison to the state-of-the-art. For application study, Table 1 shows the contribution of each lot to the final performance on the market in 1501 dataset. First, we still achieve comparative result with other math-guided and attribute-based method by using only identification lot. Then the triplet lot also demonstrates its capability on improving the performance. The center lot also shows a slight impact on the performance. Notably, the attribute lot shows stability when being incorporated with other loss functions. In overall, the performance is improved by a large margin when we incorporate all losses to the framework. Besides, in Table 2, our GBS also achieved a significant improvement over the baseline when conducting cross-dataset experiments. For comparison to the state-of-the-art, Table 3 represents the comparative result to the recent state-of-the-art on the market 1501 and 2 reality datasets. Our method achieved a competitive result in comparison with other state-of-the-art attribute-based and math-guided methods in our metric on both market and do reality datasets. In this slide, we present some retrieval example with 5 retrieve images. For each query, as illustrated, our GBS obtained better retrieval results than the baseline. In the first row, the baseline gets the 4 retrieval results at rank 5 due to the similarity of gender wearing a hat, except for the color of the clothes. By leveraging our GBS, the extracted feature are more robust to attribute and body part information, then lead to the better retrieval result for reality model. Same behavior in the second and the third row. If you have any question, please contact us.